Okay, so we have finished for the first part, okay, for numerical methods, okay, which is Gauss elimination and Gauss elimination method with partial pivoting. Okay, so now in this video, we will move to the second part, okay, which is called as LU factorization method. Okay, so in this method, okay, it will be divided into three different methods. Okay, so before we talk about for each method, okay, so we'll see the general form in solving the linear system using LU method first. Okay, so we know that for a linear system, okay, we can write into this form, right? Okay, so when we talk about LU method, okay, so we will use substitution A equal to LU. So what is L and U here? Okay, so L is a lower triangular matrix and then U is an upper triangular matrix. Okay, so I believe that you are familiar with term of lower triangular matrix and an upper triangular matrix. Okay, so you can see from here actually. Okay, when we talk about lower triangular matrix, it's actually when all the entries, okay, all the elements, okay, above the main diagonal. Okay, so this is where the main diagonal here, the main diagonal will be here. Okay, so all the element or all the entries above the main diagonal will be 0 for the lower triangular matrix. Okay, but then when we are talking about upper triangular matrix, okay, so it's somehow opposite to lower triangular matrix, where all the elements or the entries below the main diagonal will be 0. Okay, so the keyword is L for lower and U for upper. Okay, so you have to clear the difference between L and U here. Okay, so from that, okay, since we use substitution A equal to LU here, okay, so we will substitute back this LU into this first equation, okay, which is the linear system that we transform into matrix form. Okay, so we will get into this form. Okay, so from here, after we substitute this one that we use at the first place, okay, so we're gonna let U x equal to y here. Okay, so for this part, okay, we will substitute with y. And then from that equation, okay, you will get like this, Ly equal to B. Okay, so that is actually the idea. Okay, so we'll substitute the matrix, the given matrix A equal to Lu. Okay, and then from that, our new forms, which is Ux equal to Y. And after that, we will solve using Ly equal to B. Okay, so this is the definitions for an LU. Okay, so we'll see the general procedure in LU methods. Okay, so as I mentioned just now, we set this one. Sorry. We set A equal to LU here. Okay, and then you will have to obtain the component of L and U. Okay, and then from that, okay, we will solve to get Y first, okay, by using forward substitution. Okay, and after that, we will solve Ux equal to Y by solving or solve for X by using backward substitution. Okay, so like I mentioned just now, for this method, it will be divided or will be categorized into three different methods. Okay, so but the idea, okay, the general procedure, I would say for LU method will be this part. Okay, so we'll make use this idea or this general procedure in solving the linear system. Okay, so let's see the first one, which is Dolittle method. Okay, so when we talk about Dolittle method, okay, you have to remember that the main diagonal of matrix L must be 1. Okay, so this is the condition when we talk about Dolittle method. Okay, so the main diagonal here for the L should be 1. Okay, and that means that for U is similar based on the definitions for upper triangular matrix. Okay, and then the rest of the procedure will be follow for the general, like what I explained in the previous slide. Okay, so let's see for this example. Okay, I think it will be easy based on the example. Okay, so the question asks you to solve this equation system using Dolittle method. Okay, so the idea is, first thing first is to get in metric form first. Okay, so from the question given, you can transform into this one, 3, 2, 9, 2. 2, negative 1, 6, 5, 2, negative 4. So we'll have x1, x2, x3. The component for matrix B will be 28, 14, negative 13 here. Okay, so in the LU method, the first step is we set A is equal to LU. So this is A, right? Okay, so A, okay, so will be like this. 2, negative 1, 6, 5, 2, negative 4 is equal to, okay, so the multiplication of L and U here. Okay, so we know that the general form of L, okay, will be like this. Since the main diagonal will be 1 like this, so we should get like this. This one is 3 by 3, so it will be like this. So the entry that you should figure out is this one. A, B, wait, A, B, C. Okay, so this one will be 0. Okay, so based on definition for L, means that this one will be the main diagonal, right? Okay, and then all the entries, this one should be 0. So we have to figure out the values of A, B, and C. Okay, but before that, this one is for L. Okay, what about for U? Okay, so the U should be in this form. Okay, so now we have PQR 0S T 00 U. Okay, so this is how can we represent L and U. Okay, so since U is following the general procedure that what I give in the previous slide. Okay, so the concern or the changes in Dolittle method is actually for this part only, for the main diagonal for L. Okay, so this one is just follow the definitions of upper triangular matrix. Okay, so how can we figure out the values of A, B, C, P, Q, R, S, T, U here? Okay, so we will multiply this L with this U. So you will eventually get into this one. Okay, so by using matrix multiplication, you will get like this. P here, AP, PP, Q. This one is AQ plus SBQ plus CS. R, AR plus T here, BR plus CT plus U. Okay, so when we talk about Dolittle method, okay, so the general form should be always like this. Okay, so we will use this form actually. Okay, so now we will compare with matrix A in getting the values of B, A, B, C, P, Q, R, S, T, and U. Okay, so we will see from here. Okay, so we know that the values for P should be 3. The values for Q should be 2. The values for R should be 9 here. Okay, and the rest of the element, okay, you should solve it like this. Okay, so from here we know that P is equal to 3. Q is equal to 2. R is equal to 9 here. Okay, so for this part, okay, so we're going to compare with this one. Okay, so we will have that AP is equal to 2 here. Since we already know the value of P here as 3, so A is equal to 2 over 3 here. Okay, so like I mentioned, for this course, okay, so the calculation should be in 4 decimal point unless we mention otherwise. Okay, so either you use I will suggest you to use in decimal point in getting the correct answer. Okay, so for this one, we will take as 0.6667 here for the values of A here. Okay, so you can figure out the values of the rest of the, what should I say? For the rest of this one, okay, by comparing with this one. Okay, so eventually you will get that the component for L will be, after we solve it, you will get like this. 0.667 here, 1.667, 0.1, 0.5714 here, 0.01. Okay, so after you solve for this part, okay, by comparing with this value, you will get into this one. The component or the element for L will be like this after you solve for this one. Okay, so this is for L. Okay, so eventually you will get for U also. Okay, so the answer for U should be 2 here, negative 2.3354 here, 0, 9, oh, negative 0.003 here, sorry, this space is not enough, negative 1.90001 here. Okay, so please excuse for this part. Okay, so I'll write back in the next pages. Okay, so this is the element, okay, for L and U. Okay, so you have to ensure that the values that you calculate, okay, in getting the elements for an L in L and U is correct. If not, you'll get the wrong answer towards the end because you will use this information. Okay, so now, like I mentioned in general procedure, we will solve Ly equal to B first. Okay, so the second part is solving Ly equal to B. Okay, so just let me write here. Okay, because we already know the component for A or the element for A, and also we know the B. The B is given in the question, right? Okay, so we write back. Okay, 1.667 here, 0.1 here. Okay, so y1, y2, y3 here. Okay, so the component for B is given in the question, 28, 14, negative 13. Okay, so we will use forward substitution. Okay, forward substitution means that we will find the values for y1 instead of y3, like what we had in backward substitution. Okay, so from here we will get that y1 is equal to 28. Okay, and then we are getting for the y2, we have 0.667 y1 plus y2 equal to 14. Okay, so you will get that the y2 will be here is negative 4.6676 here, and then the next one is 1.6667 y1 plus 0.5714 y2 plus y3 is equal to negative 13. And then you will get that the y3 is equal to negative 57.0005. Okay, so now you got the component for y. Okay, so we will use this information or the values that you got, okay, to solve for the second or the third part will be ux equal to y, because we are actually looking for the values of x. Okay, so we know the values of for u, the elements in u, and also now we have solved for the element for y. Okay, so if we write, we will have like this: 3002 negative 2.3334. Did I make any mistake here? Okay, here is 0, 9, negative 0.0003 here, negative 19.001 here. Okay, so this is the component for u that you figure out at the first step. Okay, and then now x1, x2, and x3 is equal to the component for y that you figure out previously. So we have 28, negative 4.6676 here, negative 57.0005 here. So now, okay, instead of we use forward substitution, for this part we will use backward substitution, which is we will get the values of x3 first. Okay, so from here we will get that negative 19.001 x3 is equal to negative 005. So you get the values of x3 will be 3.000 here. Okay, and you can continue, okay, you can continue in getting the values of x2 and x1 by using backward substitution. Okay, and then you figure out that the final answer is negative 1, 2, and 3. So this is the final answer. Okay, so the idea is actually, I would say that for this method, okay, the tricky part is actually getting the correct values, for this part actually. Okay, so you can imagine by your own, okay, if you make some mistake, okay, in figuring or in finding the values of the element in L and U. Okay, so we will actually affect the whole calculation until you get the final answer. Okay, so be careful. Okay, be careful. Okay, and then when we talk about when we calculate it in 4 decimal point, make sure that you maintain that 4 decimal point from the beginning until the end, okay, to avoid any errors. Okay, so for this method, okay, I did prepare for the other examples here together with the answer. Okay, you should try by your own so that you will know actually you understand or not. Okay, I think that's all for this video. We will continue in the next video for the next method. Okay, thank you.